proportionality constant. So this K was this, right? Which is 1 by 4 pi epsilon naught. And this epsilon naught was the permittivity of the free space, right? And then we saw that what will happen to this Coulomb force when we put these two charges in a medium. Let's say we put these two charges in the water, right? Then what will happen to the Coulomb force? So we saw that this will be decreased, and it will be decreased by 1 over k times, right? So this k is called the dielectric constant, and these have some specific values. So for water, this k would be 80, right? For water, and for conductors, this k would be. So these are the dielectric constants for different materials, right? And now we will understand about the superposition. Do you have any question from whatever we have learned so far?
No, sir.
Now let us understand about the superposition. So what is a superposition principle? Let's say in the previous topic, we talked about yes, hello, Amir, assalamu alaikum. Good, good. So you joined at the right time. We are just starting. Okay.
Walaikum salam, sir.
So yeah, so we have just completed that Coulomb's law in the medium and Coulomb's law in the air. Now we are talking about, so in this topic we calculated the force, let's say, on one due to this charge. Now what will happen is that we will calculate the, so what is this so now let's say you have a test charge, right? Test charge on which we are calculating the force. So we have the test charge. Let's say this test charge is of magnitude q, and this is the test charge on which we are calculating the force. Right. And in the previous case, we calculated the Coulomb's law between two charges. Now, we are calculating the Coulomb force on this charge due to, let's say, Q1, let's say Q2, Q3, and let's say up to Qn. So we are calculating all these forces, we are calculating the force on this test charge due to this Q1, Q2, Q3, Qn. So that is when we will need this superposition principle. So due to this Q1 charge, the force would be, due to this one, this would be in this direction, right? That is F1. And let's say the separation is R1. And let's say due to this charge, this would be the force, F2. Due to this charge, this would be the force, F3, and due to this charge, this would be the force, right, Fn. So these are all the vectors. Because Coulomb force is a vector quantity, right? Force is a vector quantity. So superposition principle says that the net force, according to superposition principle, according to superposition principle, force, net force on the test charge Q would be the vector sum, right? This term is very important. Vector sum of all the individual forces due to charge Q1, Q2, and Q3. So that is the superposition principle. Is that clear, guys?
Yes, sir.
If I write it in vector rotation, net F1, F, F. My voice was faint, right? A moment ago, my voice
Yes,
was
sir.
yeah.
Good.
Why didn't you guys tell me about that? Okay.
No, sir. It was a bit slow.
Yeah, it was good. Okay, so F1 would be how much? KQQ1 R1, right? So that would be magnitude, and R1 hat is the direction. Okay, and similarly KQQ2 divided by R2 and R2 hat plus KQQN divided by Rn and Rn hat. So this would be the F. Is this clear, guys?
Yes, sir.
So now, so now before we talk about the superposition principle more, we have to learn about the general properties of the vectors, right? Because this is a vector sum, and the magnitude as well as the direction is also important, right? Because let's say that force in here is, let's say 3 Newton, 4 Newton, 5 Newton, and let's say 6 Newton. So force would not be 3 plus 4 plus 5 plus 6, because this is the algebraic sum. So force would be not like this, right? Force would be the vector sum. The direction would be also important. So let us understand about the vectors, right? Let us recall or recap vectors and vectors properties. Okay, so first thing we already that vector is the physical quantity, right? Which has magnitude as well as the direction, right, guys?
Yes, sir.
So if I represent a vector in this manner, so this is the geometrical representation, this is the mathematical representation. So in a geometrical representation, it is represented in arrows. So, and this is the mathematical representation, right? So in this mathematical representation, this part tells us about the magnitude. Similarly, length of this arrow talks about the magnitude, right? And the head of the arrow, this is the head, So this talks about the direction, as in the case of this A hat. So this talks about the direction. This, sorry guys, I have a cold, so yeah. So A hat talks about the direction, and it is a unit vector. Unit vector, yeah. So unit vector means that unit, which means that magnitude is 1. So magnitude is 1, and it only tells about the direction. Okay. So vector has two parts, magnitude and direction. This A hat part denotes the direction whose magnitude is 1, and this part tells about the magnitude, right? So we have, yeah. So we have universal unit vectors, right? We have some Cartesian universal unit vectors. So what are universal unit vectors? So these unit vectors makes our life very easy, right? So let's say we have a three-dimensional object, right? This is X, this is Y, and then this is Z. And if we take one unit direction in X direction, right? If we move one unit in X direction, so that unit vector is represented by I hat, right? So then let's say we move 5 units in X direction, so that would be 5I hat, right? So this 5 tells about the magnitude, this I hat tells about the unit vector, which is the direction, right? So in X direction, unit vector is I hat, in Y direction, unit vector is J hat, in Z direction, unit vector is K hat. So I, J, and K hat. These are called universal unit vectors, right? Unit vectors in X, Y, Z directions respectively. So what is the use of these vectors? The use is that then we, with the help of these IJK, yeah. So then with the use of these IJK, we can write any vector, right? So we can write any vector in the form of X, Y, and Z component, right? So we can write any vector in the form of I, J, and K. Is this part clear?
Yes, sir.
Yeah. So, and what is the important thing about the vectors? It has two crucial things, right? One is the magnitude, and the other one is the direction. So let's say the vector is given in this form. So we can calculate the magnitude of a vector, which is what? Which is a. So this would be simply ax square plus ay square plus az square. So this is the magnitude of the vector, and we can also calculate the direction. So we know that A is magnitude and direction. So to calculate the direction, we just divide the vector and we take this in the left hand side by its magnitude. So direction would be AXI plus AYJ plus AZK. This is the vector divided by its magnitude. So this is the direction. Is this clear, everyone?
Yes.
Okay, so please note up to this point and then we will go ahead. So please note this portion. And whenever you guys want me to scroll down, please. Whenever you guys want me to scroll down, please.
Yes, sir. Scroll down. Sir, what does the A with the arrow represent? I know it's a vector unit, but what does it represent, sir?
Yeah, A and arrow.
Yes, sir.
So this represents the vector, right? This is a vector notation.
Oh,
In mathematical way, we represent the vector in this notation, right? And usually we write the magnitude in this manner, or we can also write the magnitude in this manner. So this represents the magnitude, and this represents the direction. So these are the conventional notation for the different parts of the vectors.
Yes, sir, scroll down.
Yes, whenever you guys have noted it down, please.
Yes, sir, scroll down.
Done, right?
Yes, sir, I'm just writing this last.
Yeah, yeah.
Yes, sir, done.
Okay, so let's say that yeah, these things you guys already learned in your 11th standard, right? So let's say some vector is given which is 2I plus 4j plus 3k. Then we can calculate the magnitude as 2 square plus 4 square plus 3 square. So this would be the magnitude which is 4 plus 16 plus 9, which is 20 root 29. Right. So this would be the magnitude of this vector. And to calculate the direction, we have to divide this vector by its magnitude. So 2I plus 4j plus 3k divided by root 29. So 2 by root 29, 4 by root 29, and 3 by root 20. So this would be the direction, right? Okay, and then how are the operation? Because in the superposition principle, we are talking about the vector sum. So how the sum are defined in the vector representation, right? So how the sum is defined? So operations on so operations on vectors. Right. So first would be first would be the sum, right? Addition. So how addition is defined in the vector part. So let's say this is defined in two ways. One is in the Cartesian form, right? Cartesian form is what? So this representation is called the Cartesian graph. This is the Cartesian form of the vector. Okay. And the other one is the polar form. So this one is easy. And polar form, we will talk about two things. One would be the parallelograms law, and the other one is this triangles. These are the two laws for the polar form, right? Cartesian form is what? So in Cartesian form, the vectors would be given in I, J, K form. In polar form, the vectors would be given only the magnitude and their angle would be given. So these are the Cartesian form and the other one is the polar. So let us talk about the Cartesian form first. So in Cartesian form, the addition is simple. So in a Cartesian form, let's say we have two vectors. Let's say A, which is AXI plus AYJ plus AZK. And we have another vector B, whose also X component, Y component, and Z component are given. Right. So then the addition of these two vectors would simply be so AXI plus AYJ plus AZK plus BXI plus BYJ plus BZK. So we see that this is I hat, this is I hat. So I hat will be summed together. Oh, and Y component would be summed together. And the Z component summed together. So this is the sum. Let's say the resultant is sum. So this is the resultant in the Cartesian form, right? Let's say I have A, which is 2I plus 3J plus 5K. And B is 3I plus 4J minus 3K. So sum of these two vectors would simply be 2 plus 3, which is 5I, 4 plus 3, 7J, 5 minus 3, 2K. So this would be the resultant, right? And if we have this vector, from this we can calculate the magnitude and we can calculate the direction. So this is about the Cartesian, right? Okay, but what about the polar form, right? So in polar form, two vectors are given. Let's say this vector, its magnitude is, let's say, A, and the other vector, its magnitude is B, right? So two vectors and the angle between these two vectors is given. So we have to find out that what would be the resultant of these two vectors. So One would be the parallelogram's law. So from parallelogram's law, what do we generally do? So we make at the head of this vector, we make an arrow which is parallel to this one. So parallel to B, right? This is not to be parallel. So parallel to this. Okay. And then from the head of this B vector, we make the parallel to A. So parallel to this. This is A, this is B. So this is a parallelogram, right? And if we join the diagonal, so that would give the resultant which is A plus. Okay, so that is how we write that is how we get the resultant of two vectors with the parallelogram law, right? And magnitude of R is given by root of magnitude of A square, magnitude of B square plus 2AB cos theta. And the direction, so let's say this direction, alpha. So tan alpha is B sine theta divided by A plus B cos. So this is using the parallelogram law. Similarly, we have this triangle's law. So in triangle's law, what do we do? So we have this vector A, and let's say we have this vector B. So we take this vector in this side. So this is our B, and then we join this vector. So this vector and this vector B vector, this will give the result A plus. So we don't need this part. Just understand that if we are going in this way, we are going in this way. So resultant would be in this way. This plus this. Okay. So this is the triangle. And we get the same result from the triangle's law that the angle, so this is the angle. So the magnitude is again same. And direction, this is the direction. This is B sine theta divided by A plus B cos. So let's say that you have a question like this. So two forces of magnitude. Let's say 4 Newton and 3 Newton are acting at an angle of 60 degrees, right? So then find the angle or then find the resultant and direction of the right resultant magnitude of the resultant and direct resultant magnitude and direction of the force. So we have two force. This is 3 Newton, this is 4 Newton. These are acting and we have to find out the angle between them is 60 degrees. So we have to find out the resultant. We know that resultant is how much? that would be f1 square plus f2 square plus 2 f1 f2 cos of theta. So this is 3 square plus 4 square plus 2, 3, 4 and cos of 60. So this is how much? 9 plus 16 plus 2, 3, 4, half. This is 12. So 9 plus 16 plus 12. So this is 21 and then 37. So this is the magnitude of the resultant, and direction is how much? So direction is B, which is F2 sine theta divided by A plus plus B cos theta, right? 4 cos 16. This was the F, right? Oh, so F2 is, yeah, so let's say this is the F2, that will take it. So 4 root 3 by 2 divided by 2 plus 4 into 1. So this is 2, this is 2. So 2 root 3 divided by 5. So angle would be tan inverse 2 divided by 5. So this is the direction. This is the angle from F1 vector. So we will get the resultant like this, and this angle is alpha. So is this clear, everyone? Is this clear, guys?
Yes, sir.
Yeah, then please note down this part, and if you guys have, so these things you guys have already done, so that is why I'm just recapping. Right. So do you guys remember this stuff? Yes. So have you guys been able to remember these things? Yeah, because these portions are very important, very, very, very important. Because from the first chapter to the last eighth chapter, you guys will come across this vector terminology, vector and calculus portion in many of the topics. These portions are very important. Yeah, whenever you guys want me to scroll down, long target.
Yes, sir. Scroll a bit.
Is this okay?
Yes, sir. This is yes, sir. Scroll down. Yes, sir. Done. Yes,
Done.
sir. Yes, sir. Yes, sir.
Done. Okay. So we talked about the addition of the vectors. Now the other operation is subtraction of the vectors, right? So in the Cartesian form, that would be easy, simply, right? We just subtract I from I, j from j, k from k. So now let us talk about the polar form. So in polar form, we use the parallelograms law. And how do we calculate the subtraction? So we have this vector, right? A and this vector B. So if we take this B vector in the opposite direction, so that would be the negative vector. So this would be minus B, right? Is that clear? Right. So,
Yes, sir.
yeah, if I have this vector, let's say 3i, and I want to take the opposite vector, so that would be minus of here, right? So in the same way, if we take the opposite vector, so this is the opposite vector. Now we use the parallelograms law of A and minus B. So again, we draw the parallelogram. So this would be the subtraction of vectors, which is A minus. So that is the method we use to subtract the vectors, right? And the magnitude, so R is A minus B. Magnitude of this vector is A square plus B square minus 2AB cos theta. And direction is, let's say this is the direction that I'm taking. So this is E sine theta. You I remember this is the theta. So B sine theta and A minus cos theta. So this is the subtraction of the vectors. And the next thing which is very important. So in this way, uh, yeah, so that is very important. Always keep this in mind. So this is the most important topic, resolution of vector, right? So let's say I have the vector in the Cartesian form, right? So in Cartesian form, this is the vector. But if I'm talking about in two dimension, right? So uh, which portion we can remove if we are talking about the two dimension? This is the vector in three dimension, right? I, j, k. So if we are talking about a vector in two dimension, so we can remove this part, right? So in 2D, the vector is represented by this. So it will have two components, x component and y component. Z component is 0, right? So let's say that you are given a magnitude of a vector, right? So let's say you are given a vector which is whose magnitude is A. So then we can write this vector in two components. So this is the rectangular representation of vectors, right? So in rectangular representation, we can write any vector in two components. One would be x, horizontal component, and the other is this vertical component, which is the y component, right? So x component is a cos theta, and y component is a sin theta. So always remember this, right? This is the most crucial information. So x component is a cos theta and the y component is a sin. Okay, so then I can write this vector A in the Cartesian form as a cos theta I hat plus a sin theta j. So is this clear, guys?
Yes.
Good. So let's say I have, this is very important, right? This is the most important thing. So let's say I have a vector which is whose magnitude is let's say 5, and it is making an angle 30-degree with the horizon. This is 30 degrees. So what would be the vector? So its x component, this would be 5 cos 30, right? So which is 5 and root 3 by 2. And its y component is 5 sin 30, which is 5 and 1 by 2. So 5 by 2. So I can write the vector A as 5 root 3 by 2 I hat plus 5 by 2j. So I can write any vector whose magnitude and angle is given in the Cartesian form. So this is very important, right? We will see that how this comes handy in solving some questions. So always remember. Okay, so let's say you have a vector like this. Because the idea for doing this resolution is that addition and subtraction of vectors is easy in Cartesian form, right? So that is why we write any vector in the Cartesian form and then we can add the vectors, right? So let's say you have given a vector which is this. So you have this xy axis and the vector is this, which is making an angle, let's say 60-degree with this horizontal. And if this is the angle, then we have to write this angle only, right? So this angle is 60 and let's say this magnitude is 3. So what would be this vector? Arsalan and me, you guys tell me what would be this vector. Its magnitude is given. This is 60. So what would be a vector? You guys please calculate and tell. This is most crucial, right? So
So 3 is the magnitude, right?
Yeah, 3 is the magnitude. Oh, you will join from the next class. Your internet is lagging. Okay, but yeah, then you will miss all these questions. Yeah, please fix the internet. Otherwise, yeah, if you cannot hear my voice, then that would be problematic, right?
Sir, A arrow will be X I cap plus Y j cap plus Z j cap, right?
Yeah, so but Z component is not here, right?
Yes, sir. So,
So that would be simply AXI and AYJ. But you have to figure out, yeah, what is, you have to figure out.
hmm.
So you tell me what would be the X component? What would be X component?
So X would be,
A cos theta, that is the X component, right?
so cos 60, so root 3 by
3 cos
3.
so 3 into half. So 3 by 2, right? Y component is A sine theta, right? So 3 sine of 60. So 3 over root 3 by 2. So 3 root 3 by 2, right?
Yes, sir.
So this vector, I can write this as 3 by 2. But this is in which direction? What is the direction?
The negative.
Negative, right? So negative of I hat would and plus 3 root 3 by 2 again negative of g hat, right? So I can write this vector as minus 3 by 2 I hat minus 3 root 3 by 2 j. So this would be the vector. Is this clear?
Yes, sir.
Yeah. So, and then the last topic is, so why this is resolution of vector is important, right? So let's say that I have two vectors. So I have two vectors in this manner. This is my rectangular plane. One vector is this, and the other vector is this, right? So let's say this is 4, this is 30, this is 5, this is 60. And let's say this is O and A, and let's say this is OB. So I have OA vector and OB vector. And I want to find the resultant of OA plus OB. So in these type of question, using the parallelograms law would be difficult, right?
Yes, sir.
So then what we can do? So then what we can do is that we can write this OA vector in the Cartesian form. That would be 4 cos 30 and plus 4 sine I hat 4 sine 30 j hat. So this is 4 root 3 by 2 I hat 4 by 2 j hat. So this is 2 root 3 I hat plus 2j. Similarly, OB would be how much? This would be 5 and cos 60 minus I hat. And what would be the Y component? Yes,
So y component would be sine
5. 5 is sine 60, right?
Mm.
So minus 60. So this would be how much? So 5 by 2 minus I hat minus 5 by 2 G hat. So this is good. And then you can simply find out what is OA plus O. So OA is 2 root 3 minus 5 by 2 I hat plus 2 minus 5 root 3 by 2G. So in this way, we can easily find out the result, right? Without using the parallel. Is this clear?
Yes, sir.
Yeah, so the last topic which I want to talk about, the last operation, so that is multiplication, right? Multiplication of vectors. So we talked about addition, we talked about subtraction, now multiplication of vectors. So there are two kinds of multiplication. One is this scalar multiplication, other one is this vector. So if you multiply two vectors and then you get a scalar, so that is the scalar multiplication. If you multiply two vectors and then you get the third vector, so that is the vector multiplication. So this part we will skip for now. We'll talk about the scalar multiplication. So we have vectors, scalar product. And this is also called the dot. So we have two vectors and we want to find out the scalar product. So that would be magnitude of A, magnitude of B cos theta. And yeah, so let's say you have this vector A, this vector B, and this is the angle. So A dot B is defined like this, right? So in the right hand side, we don't have any direction. So this is a scalar quantity, right?
Mm.
So that is why this is called a scalar quantity, right? Because we don't have any direction in the right hand side. So we multiply two vectors and we got a scalar quantity. So that is the scalar, right? So let us find out that what would be I dot I. So I dot I would be magnitude of I and cos of theta. So what is the magnitude of I? What is the magnitude of I? Remember, this is a unit vector, right? Universal unit vectors. I, J, K. So what would be the magnitude?
A.
Yeah. So unit vectors. What is the magnitude of unit vectors? Let us go back to the unit vector portion, right? So we have, yeah. So unit vector magnitude is 1, right? That is why we call that unit vector. That
Yes, sir.
represents only the direction. So magnitude of I, magnitude of J, magnitude of K, all these have one magnitude, right?
Wait, so can you explain it again? So
Yeah,
the unit vector is just like it's a fixed value, right?
yeah, unit vector only represents the direction. So let's say you are moving in a line and you moved, so this is the line and you move 1 unit in this direction, 1 unit, right? So what is the magnitude that you have moved?
Only one.
Only one, right? So its magnitude would be one, but it will represent the direction in which you have moved, right? So for this case, we have moved in I hat direction, in X direction. So these unit vectors represent the direction of its magnitude is one. Clear?
Yes.
Okay. So yeah, let us get back to this. And what would be the angle between I hat and I hat? This is I hat, and this is again I hat. So what is the angle between I and I?
0.
Zero, right? So this is cos of 0. So this is 1 into 1 into 1. So I dot I, that would be 1. Similarly, j dot j, similarly k dot so all these values would be 1. Clear?
Yes, sir.
And let us find out what would be I dot j. So I dot j would be I magnitude, j magnitude, and cos of theta. So what is the angle between I and j?
So 90.
90, right? So this is cos of 90. So this cos 90 is how much?
Cos 90 is 1.
Cos 0 is 1. Cos 90 is 0, right?
Oh, yeah, yes, sir. 0.
So, so I dot j would be 0. Similarly, I dot k. Similarly, j dot k. Similarly, what is it? So these things would be right. I dot k, j dot k, j dot I. So these would be right. So whenever we are taking the dot product with I dot j, that would be here. So please note down from this solution, right? Resolution. Yeah. So from here you have not noted, right?
Yes, sir. Yes, sir. Scroll down. Yes, scroll a bit up. I missed a part.
This part,
A bit up, sir.
this
I didn't
part.
write key idea.
Yeah, so why this resolution of vector equation, right? This is just to remember that why this resolution of vector equation.
Yes, scroll down.
Yes.
Yes, sir.
Noted. Then so that is where this resolution of vector is important, right? Because doing this in the uh, parallelogram theorem, that would be difficult.
Yes, sir. Done.
Then these
Just a slow.
Yeah.
Yes, sir. Done.
Yeah. Okay, so you didn't take the class assessment in the previous class, right? Jasola? So
No,
please
sir.
take that. Yeah. So
Okay,
after
sir.
after this class, there would be some class assessment, and that would be on electric charge that we have done, right? So please take that class assessment test, and if you face any problems, so please. Okay, so we understood that. Yeah. So let's say we have a vector which is I plus 3j plus 5k, and we have vector 3I minus 4j plus 3k. So if I want to take the dot product, so we have already seen that this would be 2I plus 3j plus 5k dot. This is 3I minus 4j plus. So we already know that I dot I would be 1, right? I dot j would be how much?
I dot J will be 0.
0, right? So only the same product will survive. So only 2I dot 3I will survive plus 3j dot minus 4j will survive, and 5k dot 3k will survive, right? Others would be 0. So this is 6, this is minus 12, and this is 15. So this is how much? 21 minus 12. This would be 8 dot. Is this clear?
Yes, sir.
Okay, so please note it down, and after this class, you'll have the class assessment. So please attempt that, right?
Yes, sir.
Yeah, whenever you have noted it down, please whenever you have noted it down. Yes, noted, Jasola.
One second, sir.